Okay, let me show you what I wanted to show you. Don't worry about this writing this down. I have a picture of it that I am going to send you on Remind in just a jiffy. But I thought that if I worked this problem out, then we could talk about it real quickly before we go on to section 1.4. All right, this is the problem for from yesterday's notes. It consisted of 3 parts. It's a piecewise function because it's defined to be different things over different parts of its domain. Part of the function, remember f of x is interchangeable for y. So part of the function was just y equals 0. And what does the graph of y equals 0 look like? I just asked you on the test, graph y equals 0. Well, this is a straight line too, so you have to be a little bit more precise when you say straight line. You meant horizontal line. All right, so that piece of the graph is a horizontal line. This piece of the graph is a line with negative slope, and we're going to be talking more about linear equations and slope today. But even if you didn't know exactly what y equals negative x looked like, you could make a little xy chart for it. And the third part of the graph is y equals x squared minus 1. And maybe you forgot that that's a parabola. That's okay. Even if you don't know what it's supposed to look like, you can make a little XY chart. So what I had set up in the notes was 3 different XY charts, but you need to have in mind already that this piece of the graph is going to be a horizontal line. This piece of the graph is going to be going downhill from left to right. And this piece of the graph is going to be either a whole parabola, part of a parabola. I'm not sure until I look at the domain for each piece. Y equals 0 if x is less than -3. Some people stop their graph at -4 because they're thinking, well, -4 is the biggest thing less than -3, but it's not. There's infinitely many points in between -4 and -3. They just aren't integers. So this horizontal line has to go all the way up to -3, but not include -3. And the way you show that is with an open dot. This piece of line, its domain starts at -3 and includes -3. So that's going to be a closed dot. And then you want to go all the way up to 0, but not include 0. So I chose some x's from -3 to 0, made myself a note that the graph is going to include a closed dot on that point because of the less than or equal to. There's going to be an open dot on this point because of the strictly, I didn't get my colors mixed up, did I? 0, 0, open dot. Oh, yes. I got those colors wrong. That's supposed to be red. I was trying to make all my open dots and my less than or greater, less than or greater than without the equal to. I was trying to make the colors match and I didn't. But that does not include 0. So that's going to be an open dot. That does include -3. So that's going to be a closed dot. 0, -1 is where the parabola starts, and you are going to include that point. So you put a closed dot on that point and then pick you a few more x's to figure out exactly where the piece of parabola goes. And this is just the graph of all the points that I chose with open dots and closed dots where they're supposed to be. The most common mistake in these is to have the whole line graphed and the whole parabola graphed. If I did that, it wouldn't be a function because it wouldn't pass the vertical line test. There would be points where you could put a vertical line that would touch 2 pieces of the graph, and therefore it wouldn't be a function. All right, just in case you needed that, I took a picture last night and I'm going to send it to you super fast on Remind. And I want to make sure y'all are all getting my Remind texts. So here it comes. photo. And there's the photo. Ah, there it went. Okay, you should have gotten a picture of what's on my screen right now. Everybody get that? Does Remind give you notifications? Okay, all right. So when you see yesterday, right after class, I sent a notification, or I sent a Remind text that had those links to other videos with piecewise functions. Hallie, you said, I didn't see it till this morning. So just keep an eye out for notifications from Remind. It's probably me. Okay, and you can check that. You can check it, but all right. That's all I wanted to say from yesterday. And let's talk about linear functions and slope. All right. Tell me again what linear, in linear functions, what does linear mean? First degree. All right, so we're talking about first degree equations. And we know that the graph of a first degree equation is a line. Now, as has been the case all semester, a whole lot of this is review. Remind me how you calculate a slope of a line. Let me give you the definition first. The definition of slope is the rise over the run. Just like for a mountain climber, the slope of a mountain is how much you ascend in vertically for each foot of horizontal progress you make. And the bigger that number is, the steeper the mountain is. So how do you find the rise? If I give you 2 points, how do you find the vertical distance? You just subtract the y's, because the y's give you the vertical distance of the point. And to get the run, you subtract the x's. So there's the slope formula that you've known just about forever. If I give you 2 points, you can substitute the coordinates into that formula and get the slope. Now, real quickly, see if you can get these for examples. Draw a line that illustrates positive slope. Any line. All of our lines could be in different places. But if they have positive slope, there's something they all have in common. What is it that they all have in common? They go uphill from left to right. All right, mine, I'm going to put it there. Doesn't matter. It's going uphill from left to right, so it's a line with positive slope. And then a line with negative slope, anywhere you want to put it, just make sure it's going downhill from left to right. And then before you write something on your paper, potentially in ink, show me with your arm what a line with 0 slope should look like. Yeah, it doesn't have a rise. If I give you 2 points that have the same y coordinate and you plug them into this formula, then you're going to have 0 in the numerator. And what's the value of a fraction that has 0 in the numerator? 0. So a line with 0 slope is a line that has the same y values, and the same y values come from points on a horizontal line. And then what about undefined slope? All right, that's a vertical line, because vertical lines have the same x values. And if you take the same x values and put them into this formula, you're going to have 0 in the denominator. And you know that 0 in the denominator of a fraction makes the fraction what? Undefined. All right, so you have this mental image for positive slope, negative slope, 0 slope, and undefined slope. What you don't see anywhere on here, and this is one of the great questions in the book, what about no slope? Unfortunately, there are math teachers in middle school and high school that are using the phrase no slope. I don't know what that means. That doesn't have any meaning in math. 0 in the top of a fraction is 0. 0 in the bottom of a fraction is undefined. There's no fraction you could write that would cause me to write the word no. No fraction equals no. So don't use the term no slope. It's either 0 or it's undefined. All right. What about point slope form of the equation of a line? Now that we know the slope of a line, if I give you a point and a slope and ask you to find the equation of a line, then point slope form is what you use. That's why it's named that. Can you tell me, do you remember what that is? Perfect. And that looks suspiciously like the slope formula with the fractions cleared out. If you took this slope formula and you multiplied both sides by x2 minus x1, you would practically have this, except for this is two definite points, x1, y1, and x2, y2. This just has one point in it, x1, y1. The x and y without subscripts are the variables that end up staying in your equation. But you give me a point and a slope, I'm going to plug the slope right here and the point x coordinate and y coordinate, and then that's the equation in point slope form. Now, point slope form is most useful when you're looking for the equation of a line. It's not the most useful if you're trying to graph the line. If you're trying to graph a line, I would suggest that you either get it in slope intercept form, or down here, we'll talk about general form. Do you remember what slope intercept form looks like? Colby, do you happen to remember that? No, that was a long time ago. Jordan? Absolutely. Y equals mx plus b, where m is still your slope. And what's that b stand for, Jordan? That's your y-intercept. Very good. We usually don't use this equation to find the equation of a line, but we use this to graph. If you give me an equation that either already is in slope-intercept form or it's easy to get in slope-intercept form, that's the only two pieces of information that I need to graph the line. In this example, the slope of the line is -2/3 and the y-intercept is 4. If you were to write that as an ordered pair, what would that y-intercept of 4 be as an ordered pair? 0, 4, because remember, if a point is sitting on the y-axis, which a y-intercept is, if it's sitting on the y-axis, then x is 0. So you could either just say the y-intercept's 4, or you can say the y-intercept is the point 0, 4. Either way, if you want to graph with that information, then all you have to do is plot that y-intercept and then count out the slope. What I mean by count out the slope is the definition of slope is the rise over the run. So that -2 is your rise, and that 3 is your run. Now, what do you think when I say rise is negative? What does that mean? How do you go negative rise? You go down, all right? Instead of going up 2, as I would for a positive slope, I'm going to go down 2 and then run 3. I'm not sure which direction to run though. Do I go left because this is negative, or right? Which way do I go for that run, left or right? This is -2 over +3. So you would go down 2 for your rise, but your run is still positive. Down 2 over 3. And that is good enough. You don't laugh at my lines and I won't laugh at your lines. Now, when I said that slope is negative, so the rise is negative and the run is positive, you could look at it a different way. When you have a negative fraction, you can either put the negative in the numerator or the denominator, just not both. So we could have said the rise is positive, we would have gone up 2, and the run is negative, we would have gone to the left 3. It still would have been a point on that same line. So you can go up and to the left, or you can go down and to the right. Either way, just when you finish, make sure you look at it and go, yep, that looks like a line with negative slope. It's going downhill left to right. What about horizontal and vertical lines? You told me here that a horizontal line has 0 slope. In that fraction, for that fraction to equal 0, what would have to be the same, the x's or the y's? For that fraction to equal 0. Yeah, for a fraction to equal 0, the numerator equals 0. It would have to have the same y's. If you have two ordered pairs that have the same y's, then they're on a horizontal line. In other words, you get a horizontal line whenever y is a constant. For example, if x was 1 and y is 5, and then x was 2, y is 5, would that still be a function if two different x's had the same y? Yeah, that's not the problem. The problem is when the same x has two different y's. So this is an example of two ordered pairs that could be on a horizontal line. And sure enough, if I put them into the slope formula, this 5 minus 5 would give me 0 in the numerator, and that's a line with 0 slope. And then to get a line with undefined slope, you'd have to have two ordered pairs where the x's are the same. So you'd get 0 in the denominator. X equals a constant is a vertical line. And just make up two ordered pairs that would be on a vertical line. When x is 1, y is 7. And then when x is 1, y is just eeny, meeny, miny, mo, picking something. Y is -3. Would that graph be a function? That's what's not a function, because that's two ordered pairs with the same x but different y's. So this is a function. It would pass the vertical line test. This is not a function. You put one vertical line right on top of it, and well, all of the points on that line have the same x but different y's. So graph x equals 2. Now, I want you to be able just not to memorize that. I don't want you sitting on the test going, is that horizontal or is that vertical? I want you to think, what would it look like if all the x's were 2? If all the x's were 2, it'd have to be going straight up and down through 2. So that's not something I have memorized. That's makes sense. All the points where x is 2 is right there. And just to beat a dead horse here, remind me again what the slope of that line is. Undefined. And then the graph of y equals 2. Think if y is always the same, y gives you the height of the function. If the height of the function is always the same, then you're going straight across, just like a road with 0 slope. And what is the slope of that line? 0. All right. I try really hard to make everything make sense, to keep what you have to memorize as little as possible, because your brain's just going to fill up one day. Psychologists say no, but I say yes because my brain has filled up. So I have an acronym for you. Actually, two acronyms. The acronym HOI stands for when y is a constant, that's a horizontal line. And what do you think the O stands for? What could have, yeah, that's zero slope. That's HOI. Y is a constant, is going straight across, same height everywhere, and we call that zero slope. And then my other acronym, BUCS, stands for when X is a constant, you have a vertical line. And what do you think that U stands for? Yeah, undefined slope. I prefer that things make sense, but if you panic on a test and nothing is making sense, then reach back and pull out HOI and BUCS. It works. All right. General form of an equation. We've talked about point slope form. It's useful for finding the equation of the line. We've talked about slope intercept form. That's useful for graphing. This general form is not really useful for much. Some of the directions in the homework say get the equation in general form. So I want you to know what it is, but it's not, there actually is one kind of graphing that it's useful for. General form, I want to look in the book and make sure I'm using the same variables they do. That is objective 5. Ooh, that's the same thing you drew at the top of your paper. That's slope intercept, graphing. Ah, no, that's vertical lines. One more. General form. All right, just making sure I have the same variables they do. That is AX plus BY. Some books have for general form AX plus BY equals C. This book has AX plus BY plus C equals 0. That's the same thing. And the thing that general form is most useful for is if you get an equation in general form, it's easy to find the intercepts. You let X be 0 to find the Y intercept, and you let Y be 0 to find the X intercept. Now, if you give me something, oh, I need to switch back. If you give me something in general form, and you want me to tell you the slope and the Y intercept, how would I find that from general form? Rearrange it with what goal in mind? What am I trying to get? The Y by itself. If I give you an equation that is in general form and I ask you for the slope and the Y intercept, you're just going to solve it for Y. And once it's in that form, you can see the slope and the Y intercept. But if you ask me to graph an equation that's in general form, then I'm not going to solve for Y. I could, but there's a faster way. A faster way is to find the intercepts by letting X be 0 and finding Y, and then let Y be 0 and find X. That's particularly easy in general form. And most books I've seen called this general form, where the X and Y are on one side and the constants on the other. Your book calls this general form. So if you just get the X and Y on one side and the constant on the other, here's why it's easy to find the intercepts. if you just put down two sets of parentheses there and say, let X be 0 and 1 and let Y be 0 and 1. If the equation is in this form and you let Y be 0, well, you let X be 0, you can just put your thumb over that term. 3 times 0, 0, just cover it up and solve. My thumb is too big here. Solve negative, what if I use this one? Solve negative 2y equals 6. If you let X be 0, what's Y going to be? Negative 3. And then the other ordered pair, you let Y be 0. If you let Y be 0, just cover it up. You have 3x is 6. So what is X? 2. So that's what general form is useful for. If you give me an equation in general form, this is how I'm going to graph it. I will solve for Y if you ask me for slope and y-intercept, but if you just say graph it, I'm just going to find the two intercepts and then say, here's my y-intercept, here's my x-intercept, here's my line. All right. The last objective in this section is model data with linear functions and make predictions. This big problem on the back is where we're going to do that. We're going to talk about slope. We're going to talk about point slope form and slope intercept form. So really, you have individual examples in the book of each one of these things that we've talked about, but I'm going to tie them all together when I come back to this objective 7 on the back. There are only 3 things mentioned in 1.5, so let's go ahead and talk about those, and then we'll jump on that big crazy problem. Objective 1 and 1.5 is find the slopes and the equations of parallel and perpendicular lines. Tell me with your arms what parallel lines mean. Could be this, could be this, could be this, as long as they never intersect. They're parallel. What do you think is true about the slope that makes them never intersect? They have the same slope. If you're ever lost on a mountain, what are you supposed to do? If you don't have flares, or nope, you don't start going down the mountain, you don't start going up the mountain. If you're waiting on a rescue team, you stay still. You stay still. Because if you start climbing at a certain slope and the rescue team is climbing at that same slope, y'all are never going to meet. If you stay in one place, they can find you. But if y'all are traveling along parallel paths, you're never going to be found. So the thing that makes parallel lines parallel is the same slope, which is not one word, which I made it look like. Parallel lines have the same slope. It's a little bit more difficult to give you a mountain climbing example of why perpendicular lines are perpendicular. But does anybody remember, for example, if one line has a slope of, let's say, 2/3, what a line perpendicular to it would have for a slope? -3/2. All right, you did 2 things there. You took the opposite sign and you took the reciprocal. So my daughter, when she had algebra, used to call it opreciprocal, and I thought that was a pretty cool word. But I'm just going to say opposite and reciprocal. And that's the slope of 2 lines that are perpendicular. Now, the book, the way they write the slope of perpendicular lines, they write the product of the slope of 2 perpendicular lines is -1. But think about what we just said. If one is 2/3 and the other has a slope of -3/2, what do you get when you multiply 2/3 and -3/2? -1. So that's just another way to say, take the opposite and the reciprocal. Now, I have a feeling that you might need to look at an example in the book. And if you do, you can write down this page number. Example 1, and this is page 219. Example 1 on page 219, write an equation of a line through this point and parallel to this line. You would say, well, this line has a slope of what? 2. And so a line parallel to it would have a slope of parallel. I gotcha. Same thing, also 2. And you would use 2 for the slope and this point, plug it into point slope form. And then just in tonight's homework, make sure you're reading carefully. If it says give the answer in point slope form, it's going to be this. I keep trying to highlight with my pointer. It's going to be this if it says point slope form. The problems I was looking at last night had like an A part and a B part. The A part would ask you for point slope form, and then the B part would ask you for slope intercept form. So the second answer you just solve for Y. And then an example for perpendicular lines is a couple pages over. And this problem's a little bit harder because the line that you're given to begin with isn't in slope intercept form. So I don't know the slope of this line. How am I going to find the slope of this line? Solve for Y. When I solve that for Y, I can see the slope is -1/4. So what am I going to use for the slope of a perpendicular line? The opposite and reciprocal would be +4. I'm going to use +4 for the slope, and the point that I was given, plug it into point slope form. There's the answer for point slope form. And then here's the answer. This one I think said get in general form. So here's the answer in general form. All right. Anything we don't do an example of in these notes, there's a good one in the book. The second thing in 1.5 is interpreting slope as a rate of change. I find a lot of times folks get the number correct for slope and then don't really understand what it is when they're doing a word problem. If you're doing a word problem, that slope is the rate of change in Y per change in X. For example, if I had ordered pairs that were set up, the X's are dollars spent on advertising and the Y's are number of units sold. If I found the equation of that line, would you think it had positive, probably would have positive slope or probably would have negative slope? The more I spend on advertising, what's probably going to happen to the number of things I sell? I would expect that the more I spend on advertising, the more units I'm going to sell. So that would be positive slope. I would expect that line to have positive slope. If it doesn't, something's wrong with my advertising strategy. But what that slope would represent, and I look up here, that it's the units that describe Y per the units that describe X. So in these ordered pairs, the units on my X's is dollars and the units on my Y's is just units. My slope would be dollars per unit. If the slope was 2/3, that would mean for every $2 I spend on advertising, I'm going to sell 3 more units. And like we said, I would expect that to be positive. In another word problem, if you had the age of vehicle in years for your x's, then the units on your x's are in years, and your y's are percent of original value. What would you expect the slope of that line to be? As years go on, what happens to the percent value of your car? That's called, I just forgot the word, D. Oh. Yes, thank you. Thank you. Depreciation. Lord, I just forgot. Yeah, depreciation. The value of your car is going down. So the slope you know what? I wrote that first one exactly wrong. It's not dollars per unit. It's Y's per X. It's unit, that's embarrassing. Slope would be units sold per dollar spent. In the slope formula, the Y's are on top, so the units of your Y's are on top, and then per the units on your X's. So here, the slope would be percent, that's the units on your Y's, per year, that's the units on your X's, and you said you would expect that slope to be negative because as the years go by, your car depreciates in value. All right, the last thing in 1.5 is very fundamental in calculus. And again, we're not doing calculus, but we're starting to talk about some concepts that you'll see in calculus. In calculus, well, in algebra, we can determine an average rate of change between 2 points. In calculus, we can find instantaneous rate of change between 2 points, but can't do that yet. Help me figure out this problem, and by figuring out this problem, I think we can come up with a formula for average rate of change that will make sense instead of us just memorizing it. If you get on the interstate at mile marker 320 at 8 a.m. and you get off the interstate at mile marker 428 at 9:30 p.m., how would you go about calculating your average rate, your average speed during that time you were on the interstate? Give me words instead of numbers. How do I find speed or rate? What's that famous formula that has rate in it? I always think of it in its original form first and then solve. Rate times time equals distance. If you're going 40 miles an hour for 3 hours, you go 120 miles, right? So rate times time equals distance. And if you solve that for rate, then it's exactly what Hallie said. It's distance divided by time. Your distance may be measured in miles. Your time may be measured in hours. That's why the unit on speed is miles per hour. Or in most of the world, it would be kilometers per hour. All right, how will I find that distance? That's what the mile markers give us. 428 minus 320 would give us the distance we traveled. What about the time we traveled? How would we get that? 9:30 minus 8 o'clock? So it looks like we went 108 miles in an hour and a half. I'm going to just put that as 1.5. That's easier than using 1 hour, 30 minutes. And then I did subtract correctly. And then do 108 divided by 1.5. Somebody real quickly. You have it, Hallie? Yeah. 72, and that's miles per hour. Just like the rates we talked about up here, our units in the numerator are miles, the units in the denominator are hours, so we give this rate in miles per hour. Now, some rates of change aren't miles and hours, but look at this next sentence. Use T1 as the time you got on the interstate. At 8 o'clock is my first time. Use T2 as the time you exited the interstate. That denominator is just T2 minus T1. We could call the numerator D2 minus D1, distance 2 minus distance 1, but I'm just going to use this function notation. Use D of T as the distance you've traveled at time T. This 428 is my distance, or the mile marker I'm at time 2. And that 320 is my distance at time 1. So our formula for finding a rate of change is just D2, or excuse me, D of time 2 minus D of time 1. That gives us a total distance divided by total time. And if you look at this formula in the book, for average velocity, it's exactly what we have. Instead of using D for distance, for some reason, physicists use S for position. This is the position at time 2. That's my mile marker 428 or whatever it was, minus my position at time 1. That's my mile marker 300. Divided by time 2 minus time 1 gives me my total time. So this is nothing but rate equals distance divided by time. If you're talking about average velocity, if you're talking about average something else, it's not miles and it's not hours, then we have this other formula that we're not going to memorize because it means the same thing. That whatever x is and whatever y is, this triangle is red delta. This is delta y over delta x. That's the slope formula, the change in y divided by the change in x. This is subtract 2 y values. This is subtract 2 x values. So same formula, average rate of change when the units are anything, same formula as average velocity when units are in miles per hour. All right. Once again, we are about out of time, but we're going to talk about as much of this as we can real quickly. We're going to need to look at an example. I mean, hopefully that formula makes sense to you since we developed it, but look at an example for average rate of change and average velocity. This last, the big example on the next page or on the back of that page, all refers to this scatter plot. And that scatter plot represents the relationship between the percent of women in a country who are literate and the mortality of children in that country. I don't know if you would automatically see that relationship, but what's probably true of a country where there's a high illiteracy rate in that country? What's probably true about the country? Probably pretty poor. And in a country that's pretty poor, what would you expect of the mortality rate of children under 5? Yeah, they lack access to to vaccines and medical treatment. So you'd expect as the literacy rate goes down, the mortality rate goes up, and that's negative slope. So it appears that the relationship between percent of literate females in a country and the child mortality rate, you could say the higher the, which one do I want to say first? The higher the literacy rate, and this is specifically among women, but I think the same thing would hold true for men. The higher the literacy rate, the lower child mortality. Has a negative slope. As you read this graph, going from left to right on the horizontal axis, that's percent of literate females in the country. That's going up. But the y-axis is number of deaths per 1,000, and that's going down. All right. Why does the graph not appear to have an x-intercept? Why does it stop right there and not touch the x-axis? Well, you definitely can't have a negative number of death among children. You also, there's no country that has 100% literacy. So right on the x-axis, that would be where you had 0 infant mortality. That's not going to happen. No country has 0 child mortality. The x-intercept would be where y is 0 and your y's refer to the mortality rate. What is the y-intercept of that graph? 250? What does that mean? Yeah, in algebra, we can say the y-intercept's 250, but what the heck does that mean? Okay, and what does X stand for here? Oh, yes. In a country, I'm trying to figure out the fastest way to write this. In a country with 0% literacy, which there probably isn't a country with 0% literacy, but if there was, then what did you say the Y's would represent? The under 5 mortality. Child with 0% literacy would have 250 per 1,000, because that's the units on your Y's child mortality rate. Part D says, what's the slope of the regression line? What, how are we supposed to find that? I can tell that it's negative, but what do I need? Two points, any 2 points, and we can use one of them, and if our y-intercept, we know that when x is 0, y is 250. We need another point on that graph that hits that grid so precisely that it'll be easy to read the coordinates for that point. I was looking at it earlier. It looks like right here, it's going directly through one of the squares on that grid. Now, maybe there's another point. It's pretty close right here. It's pretty close at all the points on the line, but right here, when x is 90, I believe I can read it precisely as y is 50. So if we use those two ordered pairs, we could find the slope of the line. That slope is almost, or it's a little bit over -2. Negative like we expected. And we're out of time, but you could say what this is, because the 20 is the units on y, that's 20% per 9 children. Nope, dang it, the y's. 20 children per 9%. For each percent illiteracy rate, the child mortality rate goes down about two children per 1,000. All right, the rest of that was just find the equation of the line. I think you could do it now. We have 2 points. Hey, for those of you who didn't hear yesterday, I'm moving the test to next Thursday instead of next Wednesday, so I can be here where the majority of you are. I will have the practice test I'll have the practice test done sometime this afternoon. And I'll let you know.
Math class?
I gotta think hard, but I'll know for sure tomorrow. All right, see ya. No, I got to wondering why I skipped 1.10, because 1.10 is good. And so we're gonna cover 110. And then the day, we're supposed to have 2 days for 2.4 and 2.5. I can actually cover them in 1 day. So that's where we're gonna make up the lost day, put 2.4 and 2.5 together. No, goodness. No, and I honestly,
I don't like it to be.
no, you wouldn't like it.
Me off.
I know. A good multiple choice test is not the right answer and then duck, cow, and pig. That's obvious. The good multiple choice is the right answer and the 3 most common mistakes students make. So
I don't
no,
like it being multiple choice.
no, I wouldn't do that. See you.